Assalamu alaikum. Bismillahirrahmanirrahim. Our lesson today is called Resultant of Two Forces. At the first, we must know the meaning of force. Force means effect of a natural body on another body. How can we determine the force? We can determine the force by its magnitude, its direction, and its point of action. When I ask you to find force, you must find three things: magnitude of the force, its direction, and also its point of action. Now, let's talk about resultant of two forces. If we have two forces and the two forces act in the same direction, F1 and F2 act in the same direction, how can we find the resultant of the two forces? To find the resultant of the two forces, we make F1 plus F2. So, if the two forces act in opposite direction, how can we find the resultant of the two forces? To find the resultant of the two forces, we make F1 minus F2. If F1 greater than F2. If F2 greater than F1, so we make F2 minus F1. If we don't know which is bigger, we make absolute, because resultant must be positive value. If the two forces are perpendicular, if F1 and F2 are perpendicular, this body will move in this direction. This is the direction of resultant, but we want to find the magnitude of the resultant. To find the magnitude of resultant, we use Pythagoras. How can we use Pythagoras and we don't have right angled triangle? We can close this side, or we move F2 and close this side. Now we have right angled triangle. Its sides are F1, F2, and resultant. Resultant is the hypotenuse of this right angled triangle. So to find the hypotenuse, we make square root F1 power 2 plus F2 power 2. The angle between the two forces denoted by this symbol, alpha. Alpha means the angle between the two forces. If the two forces act in the same direction, like the first case, so alpha equal 0 degree. If the two forces are in opposite direction, then alpha equals 180 degree. If the two forces are perpendicular, then alpha equals 90 degree. If alpha not equal 0 or 180 or 90 degree. If alpha is another number, like 45, 60, 120, how can we find the resultant in this case? To find the resultant of in this case, if the two forces, the angle between them is alpha, not equal 0 or 180 or 90, another number like 60, 45, 150, and so on. So to find the resultant of the two forces, we use cosine law that we take in trig. To find the resultant by using cosine law, we make square root f1 power 2 plus f2 power 2 plus 2f1 f2 cosine alpha. Alpha is the angle between the two forces. Another case, if the two forces are equal, if F1 equal F2, if the two forces are equal, then we give them the same sample, like F. If the two forces are equal, F1 equal F2 equal F, then the body will move in the middle of the two forces. Resultant bisect the angle between the two forces. The angle between the two forces is alpha. If the two forces are equal, then the resultant bisect the angle between the two forces. This angle will be alpha over 2, and this angle is also alpha over 2. Now to find the resultant, we make 2f plus f means 2f cosine alpha over 2. Now, how can we find the direction of resultant? Direction of resultant means the angle between resultant and the first force, or the angle between resultant and the second force. How can we find the angle between resultant and F1 in this case, if the two forces are perpendicular? The angle between resultant and the first force F1 denoted by this symbol, theta 1. The angle between resultant and F2 denoted by theta 2. How can we find the theta 1 or theta 2? To find the theta 1 or theta 2, we use tan theta. Tan equal opposite over adjacent in the right angle triangle. Tan equal opposite over adjacent. The opposite to theta 1 in this right angle triangle is F2, and the adjacent is F1. So to find the tan theta 1, we make F2 over F1. If we want to find theta 2, to find the tan theta 2, look, theta 2 equal theta 2 here, because alternate, the two angles are alternating. Then if this angle is theta 2, so this angle is also equal theta 2. To find the tan theta 2, we make opposite over adjacent. The opposite to F2 is F1, and the adjacent to theta 2 is F2. So to find the tan theta 2, we make F1 over F2. To find the tan theta 1, we make F2 over F1. What about the direction of resultant in the first and the second case? The direction of resultant in the first case, direction of resultant, same direction of F1 and F2. In the second case, if the two forces in opposite direction, then direction of resultant is same direction of greater force, same direction of the greater force. If F1 greater than F2, then resultant takes the direction of F1. If F2 greater than F1, then resultant take the same direction of F2. If the two forces are perpendicular, don't forget if the two forces are perpendicular, then tan theta 1 equal F2 over F1. Tan theta 2 equal F1 over F2. If the two forces not perpendicular, in this case, how can we find the direction of resultant with the first force, theta 1, or how can we find the direction of resultant with the second force, F2? Okay, to find the direction of resultant with the first force, F1, we must find tan theta 1. We said before, tan theta 1 equal F what over F what? Right, F2 over F1. But in this case, we complete the rule. Tan theta 1 equal F2 over F1, and the tan equal sine over cosine. We put here sine alpha, and here we put plus F2 cosine alpha. If we want to find the tan theta 2, the direction of resultant with the second force, we start at first F1 over F2, and after that tan is equal sine over cosine. We put here sine alpha, and here plus F1 cosine alpha. Here in this case, if the two forces are equal, then the direction of resultant, theta 1, equal theta 2 equals alpha over 2. The last case, if the resultant perpendicular to F1, that means theta 1 equals 90. Resultant and F1 are perpendicular. Don't forget, in all cases, resultant must be in the middle of between F1 and F2. If resultant perpendicular to F1, then theta 1 equals 90. If we substitute in this rule tan theta 1 that we said in the fourth case, tan theta 1 equal f2 over f1, and complete the rule tan equals sine over cosine. We put here sine alpha and here plus f2 cosine alpha. Now substitute theta 1 by 90 degree. Tan 90 equal undefined or math error. The fraction is undefined if denominator equals 0. If f1 plus f2 cosine alpha equals 0. Now we can deduce this rule. If resultant perpendicular to f1, so f1 plus f2 cosine alpha equals 0. If resultant perpendicular to f2, if resultant perpendicular to f2, that means theta 2 equal 90. Theta 2 equal 90. If we substitute theta 2 by 90 in this rule, tan theta 2 equal f1 over f2, and tan is equal sine over cosine. Here f1 sine alpha, and down we put f2 cosine alpha. Substitute theta 2 by 90, tan 90, math error or undefined. The fraction is undefined if denominator equals 0. If f1, if f2 plus f1 cosine alpha equal 0. That if resultant perpendicular to f2. Example number 1. We have two forces of magnitude 5 Newton and 3 Newton. F1 equals 5 Newton, F2 equals 3 Newton. The two forces act at a point and include an angle of measure 60. Include an angle of measure 60, that means the angle between the two forces equals 60. Alpha equals 60. Now we want to find the resultant. I said before, when I ask you to find the resultant of the two forces, you must find its magnitude and direction. To find the resultant, in this case, we use cosine law, that we will take it in the trigonometry. f1 power 2 plus f2 power 2 plus 2f1 f2 cosine alpha. f1 5 power 2, f2 3 power 2 plus 2 times f1 time f2 cosine 60. The result will be 7 Newton. That is magnitude of resultant. We want to find the direction of resultant. Direction of resultant means the angle between the resultant and the first force, or the angle between the resultant and the second force. Any one of them. To find the angle between resultant and the first force theta 1, to find it, we use this rule. Tan theta 1 equal f2 over f1, and tan is equal sine over cosine. Here sine alpha and here f2 cosine alpha. Now substitute f2 equals 3 sine alpha 60. f1 5 plus 3 cosine 60. The result is 3 root 3 over 13. This is tan theta 1. To find the theta 1, we make shift tan 3 root 3 over 13. Theta 1 will be 21 degree and 47 minutes. Another example. We have two perpendicular forces. That means F1 perpendicular to F2. Remember, if the two forces perpendicular and we want to find the resultant, we use Pythagoras we make F1 power 2 plus F2 power 2. And to find the direction of resultant with the first force, tan theta 1, we just put F2 over F1 because alpha is 90. And tan theta 2, if we want to find tan theta 2, we make F1 over F2. These all rules if the two forces are perpendicular. Let's continue the problem. Here we have two perpendicular forces. F1 equals 6 Newton and F2 equals 25 Newton, 2.5 Newton. We want to find the resultant. To find the resultant, we must find its magnitude and direction. To find the magnitude of resultant, if the two forces perpendicular, we use Pythagoras, F1 power 2 plus F2 power 2. 6 power 2 plus 2.5 power 2. The result will be 6.5 Newton. That is the magnitude of resultant. To find the direction of resultant with the first force, tan theta 1 equal F2 over F1. F2 2.5 over F1 6. The result will be 5 over 12. Now to find the theta 1, we make shift tan 5 over 12. The result will be 22 degree and 37 minutes. Another example. We have two forces of magnitudes 50 Newton and 100 Newton. F1 equals 50, F2 equals 100. The two forces act at a point. Their resultant perpendicular to the first force. Resultant perpendicular to F1, perpendicular to the first force. Find the measure of the angle included between the two forces. The angle between the two forces denoted by alpha. We want to find the angle between the two forces alpha. And also we want to find the resultant. Now we have two requires. The first one is alpha and the second one is resultant. What about if the resultant perpendicular to F1? If resultant perpendicular to F1, so F1 plus F2 cosine alpha equals 0. Revise the rules again. If resultant perpendicular to F1, so F1 plus F2 cosine alpha equals 0. Here from this rule we can find the alpha. Substitute F1 by 50 and F2 by 100. Move 50 to the other side, it will be negative 50. And keep here 100 cosine alpha over 100 in the other side over 100. So cosine alpha equal negative half. Shift to cosine negative half, the result will be 120. Now alpha, or the angle between the two forces, equal 120. The second required, we want to find the magnitude of resultant. We use cosine law, f1 power 2 plus f2 power 2 plus 2 f1 f2 cosine alpha. f1 50 power 2, f2 100 power 2 plus 2 times f1 times f2 cosine alpha 120. Now the result will be 50 root 3 Newton. Another example. We have two forces. The greatest value of the resultant equal 32 kilogram dot weight. The unit of measuring force is Newton, dyne, kilogram dot weight, or gram dot weight. Okay, the maximum value of resultant equal 32. And the minimum value of resultant of the two forces equal 12 kilogram dot weight. This is the minimum value of resultant. Now we want to find the magnitude of each of them. We want to find F1 and also we want to find F2. Okay, we said before if the two forces have the same direction, then resultant equal F1 plus F2. In this case, resultant has maximum value and alpha equals 0 degree. If the two forces act in opposite direction, F1 and F2 in opposite direction, then resultant equal F1 minus F2 or F2 minus F1, greater force minus smaller force. And in this case, the alpha or the angle between the two forces is equal 180 degree. If the maximum value of resultant 32, that means F1 plus F2 equals 32. And the minimum value of resultant equal 12. That means F1 minus F2 equals 12. To solve the two equations with two unknowns, we just add the two equations together. If we add the two equations, we cancel F2 with negative F2. F1 plus F1, it will be 2F1. And 32 plus 12, it will be 44 over 2 over 2. So F1 equal 22 kilogram dot weight. To find F2, substitute F1 by 22 in any one of the two equations. In the first equation, substitute F1 by 22. So 22 plus F2 equal 32. Move 22 to the other side. It will be negative 32 minus 22. It will be 10 kilogram dot weight. Now we find the magnitude of each of the two forces. Also, we want to find the angle between the two forces. We want to find the alpha. We have F1 equal 22 and also F2 equals 10. Also, we have the resultant of the two forces. If resultant of the two forces, another example, two equal forces, F1 equal F2 equal F. If the resultant of two equal forces is equal 70 root 3 and the angle between them equal 60 degree, we want to find the magnitude of each of the two forces. We want to find F1 and F2. If the two forces are equal, F1 equal F2, then resultant bisect the angle between the two forces. If this angle is alpha, so this angle will be alpha over 2 and the other angle will be alpha over 2. How can we find the resultant in this case? Resultant is equal F plus F means 2F cosine alpha over 2. Resultant equals 70 root 3 equals 2F cosine alpha over 2. Alpha is 60. 60 over 2 equals 30. If we make 2 times cosine 30, the result will be root 3. F equals 70 root 3. Now we can cancel root 3 with root 3, then F equals 70. That means F1 equal F2 equals 70. So the magnitude of each of the two forces equal 70 Newton. Another example. Two forces of magnitude 6 and F. F1 equals 6 and F2 unknown equal F. If the angle between them equal 135, alpha is equal 135 degree. Find the magnitude of their resultant. We want to find the resultant at first. And also if the resultant inclines by angle of measure of 45 with the second force. If the angle between resultant and the second force F2 is equal 45. That means theta 2 equals 45. Again, resultant inclines to second force by angle of measure 45. Okay, and also we have alpha. Alpha is the angle between the two forces. Alpha is equal 135. So we can find theta 1. We make alpha minus theta 2. We will get theta 1 if we make alpha minus theta 2. 135 minus 45, it will be 90. Theta 1 equals 90. That means resultant perpendicular to F1, and we have a special case if resultant perpendicular to F1, so F1 plus F2 cosine alpha equals 0. F1 is 6, F2 unknown F, cosine alpha 135 equals 0. Move 6 to the other side, it will be negative 6. Cosine 135 equals negative root 2 over 2. F. Cancel negative with negative, then F equals 6 divided root 2 over 2, then 6 will be 6 root 2. F is equal 6 root 2. F2 equals 6 root 2. That is the first required. The first required, we want to find F, and the second required, we want to find resultant. We have F1 equals 6 Newton, F2, we got it will be 6 root 2, and also we have alpha 135. We can use cosine law to find the resultant. We make root F1 power 2 plus F2 power 2 plus 2 F1 F2 cosine alpha. F1 6 power 2, F2 6 root 2 all power 2 plus 2 times 6 times 6 root 2 cosine 135. The final answer is 6 Newton. Another example. Two forces, their magnitudes are 4F and 3F. F1 equals 4F, F2 equals 3F. Find the measure of angle between them. Find the alpha equals what? If the resultant is equal root 13F. Now we have F1, F2 and the resultant. We want to find alpha. We can use cosine law also. Resultant is equal F1 power 2 plus F2 power 2 plus 2 F1 F2 cosine alpha. Resultant is equal root 13F. Root F1 4F all power 2. F2 3F all power 2 plus 2 times F1 4F times F2 3F cosine alpha. If you want to cancel this square root, we put power 2 in the left and power 2 in the right. Okay, root 13 power 2 is 13 and F power 2. In the other side, power 2 cancel the square root. The remainder is 4F all power 2. 4 power 2, 16 F power 2. 3 power 2 equals 9 F power 2. 2 times 4, 8. 8 times 3 equal 24. F times F equals F power 2 cosine alpha. Now we move these numbers to the other sides. We make 13 F power 2 minus 16 F power 2 minus 9 F power 2. All of this equal 24 F power 2. You can cancel F power 2 from all sides. We can cancel f power 2 from all sides. Now the result is 13 minus 16 minus 9 equal 24 cosine alpha. 13 minus 16 negative 3, negative 3 minus 9 equal negative 12. 24 cosine alpha. Make here over 24 and the other side over 24. Then cosine alpha will be negative half. Shift cosine negative half, then alpha will be 120 degree.